So this is the first video on graphing linear inequalities. We're going to need to be able to do this, produce nice graphs which are well labeled, and use this information to solve problems later in the course. So a lot of you have probably seen this before, but it's good to go over this anyways. And in the first week, just focus on practicing this skill and use the first week to get your book if you don't have it. So you don't need the book during the first week. We're going to just focus on this kind of review material. So for real numbers m, a, and b, we have different types of inequalities, and these are linear inequalities because they're related to linear equations. So for example, the first one is just giving us a set of points that satisfy this inequality are the points that are either on or below the line y equals mx plus b. Again, because the equals in the less than or equals is why we say on or below. Most of the problems we'll run into in this course are going to be inequalities which are less than or equal to or greater than or equal to. But if you ever do run into a case where it's a strict inequality, strictly less than or strictly greater than, then you just ignore the word on. That means the points on the line aren't solutions. And again, keep in mind we have lines that linear inequalities where the points, we want the points above a certain line, and special cases where we are considering vertical lines or points to the right or to the left of a vertical line. If your equation is x equals some number, or x less than or equal to some number, greater than or equal to some number. And you also have horizontal lines when you have an inequality like y is less than or equal to something or greater than or equal to something. Again, for this class, most of our variables we're going to be dealing with in the problems come from practical problems. The variables generally represent quantities of some actual objects. So these inequalities, x greater than or equal to 0, y greater than or equal to 0, are going to be very common. So in the beginning, we'll just kind of focus on the algebra and the graphing of linear inequalities. Just keep in mind these basic points that we've got here. So a system of linear inequalities is just basically a list of linear inequalities like we have here. And here we have 4 linear inequalities. The first 2 involve both variables, so these lines are not horizontal or vertical. The last 2 are the typical ones I mentioned before, where the variables have to be greater than or equal to 0. So we're looking for all the points x, y in the plane that simultaneously satisfy all 4 of these inequalities. And the general idea is to first just graph all the lines and then realize which set of points do we want. Do we want the points on the line and above it, on the line below it, on the line to the right or left of it? And we basically want to shade the points that satisfy all the inequalities. And I will show you in another video how to use GeoGebra 5 to do this quite simply. If you want to use a different version of GeoGebra or use some other software, that's fine too. But I'll show you how to use GeoGebra 5. It's pretty easy and it gives decent pictures. So for this example, again, what we have is we've graphed our 4 lines. I've put them in different colors just so we can see them. In GeoGebra, this is very easy. Just type in the equation and it plots the line for you. And then you can turn the label on and off and have it label the equation of the line. Again, I'll get to that in another video if you haven't done this before in GeoGebra. And then also in GeoGebra, you'll see is I'll show you how to basically shade in the set of points which satisfy all the inequalities. Because remember, we have to interpret each of the inequalities with these phrases on and below or on and above. So we're looking for the points that satisfy all of these. So if we look at the points in this triangle, we can see they are below the blue line, which is our first inequality. They are above the green line, which is our second inequality. They are to the right of the y-axis, which is the same as this inequality x greater than or equal to 0. and they are above the horizontal line, y equals 0, which is just the x-axis. So in this case, we can see, and we'll talk later in these slides, you can read through, I talk about redundant inequalities. In this case, the inequality y greater than or equal to 0 is redundant. If we removed it from the system, we would still have the same solution region or set of points that solve all of these. Another thing we want to be able to do is when you're presenting a graph, which we will use to solve some problems, not only do you want to label the lines, label the region, but you want to label the corners or vertices of the region. And since all of the regions are going to be formed by lines, they're going to be regions that have a bunch of flat edges and some corners or vertices. So those corner and vertice points are going to be crucial to solving problems we do later. So we want to be able to identify those points. Again, using GeoGebra, you can just plot the polygon, in this case a triangle. Once you have the other picture, I just added a triangle, and then I turned on the labels for the vertices of values, which just gives me the points 0, 5, 0, 2, 1.59, 2.35. Just keep in mind that GeoGebra is not going to give exact values always. It's going to round to a couple decimal places. For presentation purposes, that's fine. But we definitely want to be able to create graphs like this one for these two variable problems. This will be a good reference for describing your solutions to linear programming problems that have two variables. It'll allow you to identify which of the vertices is actually the solution to the problem we want. Generally, we're going to be maximizing or minimizing some function over the set of points in our solution region, which we're actually going to call the feasible set of solutions once we get to linear programming problems. For now, since we're just talking about the basic algebra idea of graphing linear inequalities, we'll just call it the solution region. And keep in mind, this isn't presented in your book because it's generally a prerequisite for this course, but use the first week, just kind of practice this skill before you get the book, and then we'll move on. Main thing I want you to keep in mind when you are creating graphs for problems is make sure all your lines are labeled with their equations. If you use GeoGebra, watch the other video and you'll see exactly how to do this. Again, label all the vertices of and their coordinate values. Just shade the solution region. Again, this is all very easy in GeoGebra. And then again, make sure that whatever you do with your image, or however you make it, you import it into your final document that you'll be submitting for either a written assignment or an exam review assignment, or exam 3, which will actually be a take-home assignment and may ask you something that needs a graph. Again, other things to consider, your font size, coloring, but just generally make it a nice picture so it's easy to read and know what it's portraying. From an algebraic point of view, just remember that when you're solving inequalities as opposed to equations, when you divide by negatives, you have to reverse the inequality. So again, I just illustrate here how you can solve a linear inequality of this form for y, because putting it in that form allows us to see symbolically which side of the line we're looking for. If I see a y greater than or equal to, I want points above or on the line. If I see y less than or equal to, I want it on or below the line. So again, depending on the algebraic steps you choose, you get to the same answer, but you have to be careful with the inequalities. In method 1, I went ahead and said subtract the 6x from both sides and then divide by the -4. But dividing by the -4 means we had to swap the order of the inequalities. And in method 2, I just used adding and subtracting of terms to get to the same thing. The only difference is the quantities in the inequality are just written on different sides of the page, but the inequality is the same. Again, I already mentioned kind of redundant inequalities, but again, just keep this in mind. In reality, a lot of redundant inequalities in a system could actually slow computer processing time. But this is only if you're talking about very high-level industrial problems where there's hundreds or thousands of variables and hundreds of thousands of linear inequalities in your problem. For the things that we're going to do, this is not really an important issue. But just be aware of what redundancy means. And in some algorithms, redundancies can cause other problems. We may or may not discuss those later in the course. If we do, it'll just be kind of a side note. Again, when you're solving a system of linear inequalities, there's basically four things that can happen. As in the first example we had, your region could have be some kind of area on the plane, which has straight edges and possibly some vertices. This region could be what we call bounded or unbounded. If it's a polygon, like our triangle in the previous example, it's a bounded region, but it may be an unbounded region. What we'll see later is, generally speaking, when we're doing a minimization problem, oftentimes our region will be an unbounded region. But that's okay because we're minimizing. And we'll see that the solution will come from one of the vertices on the kind of lower part of the region. What could happen is your set of points that satisfies the system could only be on some line or line segment of points. Or you could have a single point as the only point satisfying all the inequalities. And finally, the last thing is there are no solutions. Basically, your inequalities don't overlap, or they don't all overlap. Remember, they all have to overlap to get a solution region. If any one of them doesn't overlap with the rest, then you have no solution, or the solution region is empty. That's what we mean by this. So I said, this is just review stuff, so a good practice exercise to do is try to create your own system of linear inequalities with at least 3 or more inequalities that will satisfy each of these types. And then go ahead and graph it using GeoGebra after you watch the GeoGebra video that I put up.